what is heat? Basically, in simple word, if I say the heat is basically it's a form of
energy.
Yeah, it's a form of energy. The heat is basically is a form of energy, right? So it
Yes.
derives it from origin at the molecule scale. So there are some molecules, it will start driving from there, right? So the molecules
Yes.
of substance vibrate at their position either fixed or not when energy is supplied to them. Getting it?
Yes.
So
Yes.
as they vibrate, they transfer their energy, right? As they vibrate,
Yes.
they will transfer their energy to the surrounding molecules, right? The example when you boil your water, right, on a gas,
Yes.
correct? So first it is cold, right, and then started hot, then it's surrounding elements, right, it's surrounding
Yes.
molecules, right? So the surrounding molecule causing them to vibrate as well. When the heat is transferred to one system to another system, for example, there is an equation called Q equals to M into C into delta T. Okay. So what Q is denoted? Q is denoting the heat.
Right.
What is M? M denoting the mass.
Mass.
What is C? C is denoting the specific heat.
Heat.
And what is meaning of delta T?
Temperature gradient.
Yeah, temperature
Or
gradient
temperature
or
difference.
difference. Very good. Difference in temperature. In thermal, there are three mode of heat transfer, correct? So
Yes.
what are those mode of heat transfer is? First is conduction.
Conduction. Second is convection.
First is conduction. Second is convection.
Convection. And third is radiation.
Very good. Third is radiation. If I again summarize like how the heat is transferring basically. So the heat transfer happening. So the transfer of heat is normally from high temperature object to the lower temperature object, right? How the heat will transfer? So theoretically we already have studied the heat transfer. The transfer of heat, you can say, is normally from a high temperature object to
Low temperature object.
lower temperature object. This we have studied in the book, correct?
Yes, sir.
We know there are three mode of heat transfer. One is conduction, second one is convection, and third one is the radiation. Okay, so let's understand what is conduction. Again, in all three modules there will be a transfer of heat, correct? So the transfer
Yes,
of
sir.
heat is normally from high temperature object to the lower temperature object. The heat transfer via the molecules contract or vibrate each other. This is how they will transfer, right?
Yes, sir.
The very good example is cooking pan, right? So when we
Yes.
heat the cooking pan, let me take
The
it.
handle also get.
Yes, correct. So let me take it let me take this image here. Few circle, okay, and then attached to this circle there are some more circle, okay.
Yes.
Getting it? So these are basically molecules, right?
Molecule.
You getting it, right?
Yes, sir.
I'm just drawing with my pen, okay, and if I want to fill it, for example, this is completely red, right? So this is the lower part of your pen, right?
Yes, sir.
So this is my completely hot, you can say. So we know what we know. We know the heat will transfer from this part to this part, correct? When the molecules
Yes,
will
sir.
contact and they will start vibrating it, right?
Yes, sir.
So let me make it them first as a hot. So these are my hot. Okay. Now the initial they are hot, right? And
Yes.
let's say these are the cold one. Okay, so this is the basically cold one, right?
Yes.
So what happening here? The heat will transfer from hot to the
Colder side. Yes.
cold side, right? From hot temperature to the lower
Low
temperature of the
temperature.
object, correct?
Yes,
And
sir.
yeah, the best example is the cooking pen, right?
Yes.
So what happening here? So this is my, let's say, first iteration, okay, first. Then what will happen next? The next you will see that, okay, so what happened when the next?
The second column of molecules will turn
Yeah,
orange.
correct. So this become hot now. It's coming in contact,
Yes.
so this also become hot now, right?
Yes.
Correct. So all this, right, become hot,
Yes.
and this one become your cold, right? Still there are some molecules which are present here and they are cold. The heat is not reaches there, right?
Yes.
Still the heat is not reached there, right? So you can say cold. Now after filtration, what will happen? Everything become
Hot.
yes. So this one, your entire body will become hot, right?
Yes.
So you already observed that, right? What you observe in a when you're heating the cooking pan, from the bottom, and after some time the heat will transfer from hot zone to the cold zone, correct? As we saw this example here, from hot to cold, then hot to
Yes,
cold,
sir.
right? And then it become completely cold.
Yes, sir.
So hot zone of a metal to the cold zone, then next hot to the cold zone, and then next all surface become hot, right? In the third one, correct? So this
Yes, sir.
happened because of the conduction phenomena.
Yes.
But you see here in the pan, there is a plastic cover, right? There's a plastic hand cover that protect
Yes.
our hand from burning, right? So
Yes.
basically, this is the reason where the plastic cover are feeded to. Even if you take a spoon, right? Example, if you don't have a plastic cover on the spoon, then you will feel, your hands are burning, right? Your hands are
Yes.
start burning. But here, that is the reason that people put the plastic cover to protect your hand from the burning and
Yes.
to avoid the conduction here, right?
Yes.
Conduction basically it heat transfer observed in all type of phase, correct? All type of phase
Yes.
means what are those phase? There is a solid, right? There is a liquid and
Liquid and liquid.
there is a gas, right? So it observe in all type of
Phases.
phases. Okay. What are those phases?
Solid
Solid, right?
and fluid.
Fluid, yani liquid, you can say.
Fluid and gas. Yes.
And what is third one is the gas, correct?
Yes.
Now, how it is going to transfer in the solid? It is due to the lattice vibration. It is due to the lattice vibration, translation and rotation, and mainly due to the free electrons, right? Like copper,
Right.
aluminium. These all are the good conductor of the electricity,
Heat.
right?
Yes.
So in solid, because of the lattice vibration of their molecules, okay, and liquid, it is due to the molecule. It is due to molecular movement,
Moment
okay.
transfer.
In gas, it is due to molecular collisions.
Collisions. Yes.
Clear? So
Yes, sir.
it is due to lattice
Vibration.
both in translation and rotation also, okay.
Okay.
And here it is due to
Molecular moment transfer.
exactly the molecular movement. Molecular movements, okay. In gas, it is due to
Molecular collision.
molecular collision.
Yeah.
Okay, understood? So,
Yes, sir.
conduction basically, its heat transfer is significantly, majorly observed in the solid.
Solid.
Okay. So, when we mostly will see it is significantly observed in the solid bodies. Okay. There is a Fourier law govern the conduction behavior.
Conduction. Yes, sir.
Correct. So, for example, there is a very wonderful example we already saw in our in Indian houses. The example is there is an Indian heater, right? Correct. In the old time, people used to have an Indian heater. Yeah, look at this.
Okay, okay.
Fourier laws govern the conduction behavior, and that example is the Indian heater. This is our Indian
Heat.
heater. So what happening to this Indian heater? The heat energy provided by the electricity, correct? The
Yeah.
amount of heat to transfer from this per coil, right? There are some coils, right? Amount of
Yes,
heat
sir.
transfer from the per coil per unit time
Yes.
is called heat flow rate, Q.
Yes.
Clear?
Yes,
I
sir.
will repeat. What is that heat flow rate? Rate means the heat
Amount
energy,
of
yeah, the heat energy, which is the heat energy, from where it is coming from the electricity, right? So the heat
yes.
energy provided by electricity and the amount of heat transfer, the amount of heat transfer from heating coils, these are my heat coils, right?
Yes.
So the amount of heat transfer from the heat coil per unit time is
Yes.
called heat flow rate Q, denoted
Q.
by Q. And if you divide this Q, if you divide this Q, right? If you divide
By
this
area.
Q by area, by the cross section area of this heat coil, then we will
It
get
will
heat
flux.
heat
Flux.
flux. Very good. So it become Q equals to Q by A,
A.
right?
Yes.
Understood?
Yes,
Right.
sir.
So we call as a heat flux. So the thermal conductivity, there is a one term arriving here. Thermal conductivity.
Yes, sir.
We will denote that with K, correct?
Okay. Yes, sir.
What is the simple, very simple, meaning of thermal conductivity is it describes the ability of the material to transfer the heat. Correct?
Heat. Yes.
Right?
Yes,
Thermal
sir.
conductivity means that describe the material ability to transfer the heat.
Heat.
Okay. So here in this case, the larger the K, what will happen? The larger the K means जितना ज़्यादा K होगा, the larger the K, the transfer, right? The transfer and faster the heat transfer through conduction. Correct? The larger,
Yes.
the larger the K, the transfer of the heat, right? The transfer or faster the heat through
Conduction.
conduction. Clear?
Uh-huh.
It's clear to you, right?
Yes, yes.
We came to know about Fourier's law, right?
Yes, sir.
Fourier. So let's, write the equation where the Q equals to minus Ka dt by
Yes.
dx. What is this equation is?
Fourier's law.
Fourier's law, right? So the Fourier law's equation is the Q equals to minus Ka dt by dx, right? So what is
Yes.
Q? Q is nothing
Rate of
but
heat
your,
transfer.
yes, correct, your heat transfer rate. That we will denote it by W, correct?
Yes. Yes.
And what is A? A is the area,
Yes.
right? We'll keep that into millimeter square, okay?
Okay.
And what is dt? dt is the temperature difference. dt is the
Temperature difference.
temperature difference. We'll keep it based on the input that we are having, like degree centigrade, Kelvin
Yes.
and radian. And what is dx is thickness.
Thickness, right.
We'll denote that into millimeter. Okay. And very important term called K. K is nothing but your thermal.
Conductivity.
The unit of thermal conductivity is
Watt per meter Kelvin.
watt per millimeter Kelvin or meter Kelvin,
Yes.
right?
Mm.
Now, you already know from the last formula what is that? The Q equals to, what is that? Q equals to,
MC delta T.
no, from the heat flux,
Q by A.
capital Q by A, right?
Yes.
So if I write here small q, then,
Minus K dt by dx.
right, understood from where it is
Yes, sir.
arrive?
Yes, sir.
Q equals to minus K. So write this one, heat flux, correct?
Yes, sir.
Okay. So
Yes.
what happening here? Q, small q equals to minus K dt by
Yes.
dx, right? dt
Yes,
by
sir.
dx, correct? So there is a, if you look at here on the K, the temperature gradient, if you see there is a minus signs, correct? There is a minus
Yes,
sign,
sir.
right? So the temperature
Yes.
gradient with a negative sign, as the temperature gradient vector is in the opposite direction of the heat flow. So the minus
Yes.
sign indicate that the temperature gradient assigned with a negative sign, it means the temperature gradient vector is in the opposite direction of the heat.
Heat flow.
So this is the heat flow equals to minus K dt by dx, and the negative sign indicate that the temperature gradient vector is in the opposite direction of the heat
Flow.
flux or heat flow. heat flow.
Yes.
Opposite direction in the heat flow. Where, if you look at here, dt by dx, so according to the Fourier law, for the given amount of heat flux, larger the thermal conductivity, if I increase the thermal conductivity, larger the thermal conductivity is smaller the temperature gradient, right?
Yes.
So according to the Fourier law, for the given amount of the heat flux, larger the thermal conductivity, smaller the temperature gradient. So this is my temperature gradient. Okay. So the minus sign indicate that the temperature gradient vectors is in opposite side, right?
Yes.
Opposite direction, you can say. Opposite direction of heat flow. Clear?
Yes, sir.